Hi everyone, I am again along with you with the new episode and new topic in this series of Worth to Know Current Affairs. And here I am today going to discuss some of the very important and very unique in itself kind of event that took place in the month of October. And this is something which going to change the course of science and the perception towards the looking at the science and the potentiality of the science, and that feat, that particular accomplishment that is achieved by the NASA and one of the leading space agency of the USA. And in this session, what I am going to discuss today is that the topic of NASA, which is very much in the news, that is NASA's DART mission. So DART mission is generally refers for the world's first planetary defense test. This is kind of test which implemented and that is something pursued by the NASA. And in this test, what is important, that is a different thing, but this is important for the point of exam for the UPSC in the paper 3, where maybe a question that can be asked. So in this year means we have seen the questions from the recent NASA's, that is and the European Space Agency and the Canadian Space Agency. They have collaboratively launched the James Webb Telescope, and that is asked in the GS paper 3. So these kinds of experiments and the space missions which having a very huge impact in the humanity and the science fraternity, and these are the areas where UPSC are also interested. So that is something keeping in the mind the requirement and demand of the UPSC exam. So we are going to having some in-depth analysis and understanding towards this DART mission. So let us start this DART mission. As I have said that this world's first planetary defense system. So what is this planetary defense test? That is we are going to understand a better way in today session, and that is what the double asteroid redirection test, something the terminology which is maybe not familiar to you, all of you, but what we are going to discuss. So DART is something a first ever mission, that is keeping in mind this is the first time this kind of mission took place across the globe, and by the NASA, that is to investigate and demonstrate the method of asteroid deflection. The asteroid deflection is a method in which the asteroid, the orbit in which in path that particular asteroid or any celestial object is orbiting or revolving, so that's very path of natural path of that particular asteroid or any celestial body can be deflected, that can be deviated from its course. So this is something that level of experiment which is undertaken by the NASA scientist, and by changing the asteroid's motion in space through kinetic impact. So this is kinetic impact, how it is going to important, and what is the something important about kinetic impact, it is also need to be understood. So we'll discuss in the later part. So goal, first of all, what is the goal of this DART mission? So the demonstration of asteroid deflection with a kinetic impact, and this is the goal which we need to having in the mind. And what is the statement of the NASA is to save the humanity from the potential cataclysmic collision. So that is something NASA is with that kind of endeavor, which is we can term as from the sci-fi Hollywood movie, that is the Guardian of the Galaxy. So that is kind of what the test undertaken by the NASA. So what are the targets? The targets, the asteroid, the very name of that asteroid particular is the Didymos, and it's moonlet dimorphos. So that is something 1.7 crore kilometer away from our Earth, and in that distant place in our galaxy Milky Way, that Didymos and its moonlet dimorphos, their very orbit, their natural orbit is what they went for the deflecting their orbit. So that was the target, and the mission duration, this is something for the factual part, for the maybe prelims aspect, that is 23rd November 2021 when it was launched, and it attained its target at the September 26, 2022. So that was the impacting date. So this has been in the news at the month of October. And what is and how it worked, that is important, so we can have some diagrammatic representation where we can maybe have a better understanding. So NASA's spacecraft crashes into asteroid moon. That is how this is the Didymos, the asteroid, and its moonlet, that is Dimorphos. The original path was the this white colored orbit where it was going to it is about to revolve, but later when it collided with the help of this DART mission, then its new orbit will be this yellowish color part, or is yellowish orbit. So the question is why NASA went to now strike that particular Dimorphos, that moonlet of the Didymos. So that is the calculations of the scientists and their the way of calculation. They came into the conclusion that if that particular Dimorphos stop not to orbit in this particular Didymos orbit, then possibly due to gravitational pull of the Earth system, it may enter into the our atmosphere, and that may lead to the some catastrophe, or that may some able to collide the any place in our Earth. So that is something, maybe a human problem or human catastrophic event that may occur in the future. So that was the apprehension and the NASA scientists of the view, so that they endeavor to direct this particular orbit. So this is what about the given by the John Hopkins Applied Physical Laboratory, NASA's space agency. They have given this idea. And if we see what is the what are the dimensions of this DART mission. So DART is something, a satellite kind of space object, that particular mission, that is about 19 meter in the diameter. But if we see the Dimorphos, that is 163 meters. So 163 meter, how can we assume this meter? So we can just take the 1 football ground, that is about 100 meter of the length. So that is more than half, means 1.5 or 1.6 times football ground, that Olympic size or FIFA size football ground. So that is the dimension, that was the size of Dimorphos. And that DART mission is just about 19 meters. So 19 meter is something 6 to 7 it's about 5 to 6 floor of the building is about 19 meters. So that is the one building you can assume of about something about 5 to 6 floor. So that is going to went to hit this Dimorphos of the something 1.6 size of the football ground. So that is something very different, and we can assume here, given that case, Statue of Liberty, that is about 93 meter height, or Eiffel Tower, that is 321 meters. So that is something a dimension. And Didymos, the asteroid, very asteroid, is 780 meters. So that is near to, not exact, but that is something 220 meters short from being a 1 kilometer size. So 1 kilometer is a bigger size. So that was Didymos, that is, and Dimorphos used to orbit that. So what is the backdrop now? What is the idea where NASA came into the that idea of the launching this DART mission? So that is NASA arm. So that is NASA arm is a special agency, a special project of the NASA, and that was the idea that in the that conceived in the year 2013, that asteroid redirect mission, and that went for the about hardly 4 years, that is to 2013 to 2017, and DART as a part of that mission, so that they can achieve that, to bring closely space rocks in the order to study and mine REM. So this is something takeaway, that REM, that is rare earth mineral. So the core of these missions are actually the rare earth mineral. We have seen, I hope you might have been watched the movie Avatar. So in the Avatar, we have seen that how the entire mission to that particular planet, their idea to extract out the rare earth minerals, which are going to be very expensive, and they can be marketable in the earth back. So that was the idea, and that is how we know that every activity, the economy is the backbone, and For that matter, NASA also trying to leverage these rare earth minerals so that their mission can be justified. So, but the same time they also said that this is the something to save the humanity, like they are going to that kind of role of that guardian of the galaxy, as we have I have said earlier. So that is something a certain the feasibility that what can be the potential of this future Martian mission 2030. So at the same time they also of the view that the future projects till date we know that we have in the NASA's programs have sent the man mission in the moon, but not to the Mars. So Mars is one of the potential and the very prospectus in the NASA's and the every agency. Even in India, ISRO is also looking forward to have the missions that is endeavoring to understand and explore the Mars as well. So Mars is one of the mission. Mars is one of the planet where every agency of the world are looking for, and they are trying to attempt some of the projects for that. The earlier attempts to prospecting rare earth minerals, very first time the Soviets were the pioneers. They launched the Luna mission in the 1970s, and later on an Apollo human space mission that is undertaken by the NASA, the space human mission, and thereafter Stardust mission, that is to comet wild 2 sampling in the 2004. Then Japanese went for the Hayabusa JAXA in the year 2003. Then Osiris-Rex to explore the Bennu asteroid and to samples there. And then Chinese in the year 2020 recently they have attempt to explore the lunar samples and carried back to the earth through the help of Chang'e's 5 missions. So these are the missions which are actually trying to prospect the rare earth minerals. So the keyword here is the rendigious and the REM, rare earth minerals. Rendigious is something that if the orbit of any particular celestial body and the particular object or any space project or any space objects like any satellite or any spacecraft, if that attain the same orbit with the natural orbit, so that is that meeting of the orbit, that co-terminus of the orbiting or similitude in the orbiting is known as the rendigious. So REM, that is rare earth mineral, that is very important. And kinetic impact, where we need to understand kinetic impact is that, as we have discussed, that DART mission was very much smaller compared to the DADMOS. So but how that particular DART mission could achieve that mission to deviate that particular asteroid moonlet, that is because of the kinetic impact. So that is something when any object in the motion, if that is of the particular mass or particular weight, then it can attain the multiplier impact. That is we in the physics say called as the kinetic impact. That because of the motion, because of the velocity, or because of the any speed of that particular object, that impact or collision can be enhanced, that can be aggravated. So that is the kinetic impact. That is very as simple as the Newton's that theory of motion. And the comet is something, the extracelestial bodies which are generally under the influence of sun's gravity. So that is the comet. And asteroid, we know that various time we sometimes these kind of asteroid between the Jupiter and the Mars, we have seen, maybe everybody I hope watched the Shaktiman, in which Shaktiman whenever tried to fly over the sky to reach somewhere, then he come across the various asteroids at that kind of celestial body. So that is the asteroid. So this is basically the key terms and the terminologies having their specific definition and meaning. Now why important the race for rare earth minerals? Now this is important. What is the significance of these rare earth minerals? Because of the utility. That is a simple answer as this is. So rare earth minerals are used for maybe everywhere. As we have now embarked into the journey of that industrial revolution 4.0. So this is how this modern revolution, where internet of the things, where 5G telecommunications, where space missions, and every activity somewhere programmed, somewhere that is enabled by the chip, that semiconductors, our endeavor for the green energy, switching from the conventional source of energy to the that electric, that solar energy, wind energy, and electric vehicles, and everywhere that is in the use. So rare earth minerals have its own unique capability to cater these needs of the humans. So if we have to succeed, get accomplish this industrial revolution 4.0, then rare earth minerals going to be a very much game changer, and it's going to be a very much of the high significance. So whether that is there are about group of 17 elements in the wide range of consumer products, as we have seen the, and what is important, everywhere the wind turbines, the hybrid vehicles and the iPods, everywhere the use of that, fiber optics for the 5G technology, energy efficient fluorescent light bulbs, everywhere we are very much conscious, and as we have seen that issues of that this climate change or climate catastrophe are there. So that is to be addressed, and that can be addressed by these rare earth minerals or elements. But at the same time, what is important here, that if we see this pie chart diagram, that how US, the country particular, using the rare earth minerals in its industries. So we have seen the large 62% of use of these rare earth minerals in the petroleum refining, in the catalytic converter in the vehicles, where pollution to be controlled, industrial pollution scrubbers, then chemical processing in the industries, the rare earth minerals is used. So about major part of that is, we can say, the lion's share of these rare earth minerals are used in the industries and the vehicles. But some other uses are the metallurgy in the aeroplane, in the steel additives, the hybrid vehicles, as well as the optical glasses, protective eyewear for the that is for the personal appliances, and satellite electronics. Everywhere we can see the wastewater treatment, radiation monitoring in the nuclear plants, or maybe in the medical hospitals. So these are the uses of the rare earth minerals, in particularly in the USA. So same kind of uses will be there in the other part of the world, and like osmium, iridium, that scandium, palladium or thorium, these are the some examples of the rare earth minerals. And if we see, this is the going to the part, this is the diagram which is important because of the how rare earth minerals going to be a play as a centrality to the geopolitics. So if we see the availability or deposit of the rare earth mineral across our earth, here United States, then Canada, then Brazil, then Russia, then China, then Australia, then Vietnam, and South Africa, and India. So these are the countries those are having with the deposit of the rare earth minerals. But here the leading producer is the China, and probably that is that's why China is leading in every industries. That's why China's industries, China's everywhere, like automobile, like telecommunication, cell phones, mobile technology, we can see that China is leading in the present era. So that is maybe because of, we can say with this inference, that China is because of the rare earth minerals. So that's why countries of the world, particularly major emerging and economic powers, including India, they are striving towards exploration of the, or finding out the deposits of the rare earth minerals. So obviously that is going to be important. In India, we can see some parts like in the state of Assam, in the Haryana, in the Rajasthan, some part of Karnataka and Tamil Nadu and Jharkhand, we can see, and even in the Chhattisgarh, there are some potential or some prospectus of these rare earth minerals where we can have, or India can leverage from there. So these are the rare earth uses. We have already discussed how. For an example, how scandium is used. The scandium can be used in the aluminium to form an alloy. Alloy is a mixture with the aluminium and scandium, which finds use in the sports that equipment like baseball bats and sticks and bicycle frames. So bicycle frames, we have seen the very much of the cycles which are very much strong and highly expensive in using in the very much maybe that is 1.5 lakh, 2 lakhs, and maybe even 10 lakh cycles, bicycles are available in the market. So why they are expensive? Because of this scandium alloy that is used. So that is very much high in the strength, their flexibility, their that strength of that particular alloy will be very much high. That's why they are very much long lasting in nature. So that's why their prices are very much high. And even in the like iridium, that is one of the rare earth minerals. Iridium is used in the that ignition, the sparking plugs of the vehicle. And if that iridium is used, that is with a very much high melting point, so the vehicle no need to change or replace in the normal interval, where when like going for the servicing, generally that sparking plugs generally got used. So that is no need to replace if we place the sparking plug that is made up of the iridium. So iridium is of that nature. Now the bottom line. So what is we have discussed the DART mission, but what is the bottom line? So what is that key takeaway here? That is that while ostensibly that apparently the drive comes from the desire to save the humanity uh, uh, from that particular moonlet asteroid, that is the killer asteroid, but perhaps the idea or the idea behind that particular endeavor or that particular mission is for the lure of the space mining, that is actually the attractive, that is the core magnet, and the lurks behind that supply shortage of the REM, that is rare earth minerals, so that to get the sufficient or adequate reserves and supply, so that we can achieve our goal of industrial revolution 4.0. So that is very much important. At the same time, what is important here, and that is in the conclusory remark, as that is the since mining REM comes with the heavy environmental costs, so maybe in the future we can have the any space mission where we can extract all the rare earth minerals from some kind of asteroid or in the planets, so that we can save our very precious and one and only our earth system, where we can survive and sustain our any and every endeavor. So with this, I thank you all. Thank you for being with me.